it was here I was saying that this is the this is the this is the upward force. This is the upward force. This is the backward force. This is the backward force. This is the weight, which is down, and this down here is our forward force, our driving force. So this is what we have, and then we are told to this version of WhatsApp you cannot change. So this is up, this is forward, this is down, and this is backward force. So we were saying the weight of the car is given by mass times gravity. Then to find the mass, we divide by the gravity, we divide by the gravity, so that this cancels, and our M mass will be equal to weight, which is 8,000 divided by gravity, which is 10, and our mass was 800 newtons. 800 newtons. To the resultant force, I was saying that when an object is moving, what causes it to come to rest? It's because of the backward force, and the force that makes it move forward is a forward force. So the resultant force will be the difference between the forward force as well as the backward force. So we'll say resultant force is equal to forward force, which is force B minus force D, which is the backward force. And then our force B is 1000 newtons minus the backward force, which is 600 newtons, and the difference here that we'll have is the answer when you subtract is 400 newtons. But remember, force is a vector, so if we're asked to describe the direction in which this force is going, we have 400 newtons in a forward direction, because forward we have got 1000 newtons, backward we have 600, so we have more of the force in the forward direction by 400 newtons. That's our resultant force. So it's because of this force that caused this car to accelerate. And that's why this question says find the acceleration. So we say force is equal to mass times acceleration. So to find the acceleration, we are going to divide force by mass. So we say force over mass. And our force is 4,000 newtons, and our mass is our force is 800 newtons, and our mass is 800 newtons. So when we divide that, you'll find that our 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 acceleration will be 0.5. So our acceleration is 0.5 meters per second squared. So this is our acceleration. This is what we have. This is what we have on this diagram. The other question that we have is, and that was the end of it for Max. The other question that we have is this one. It's talking about work, power, and energy. Work, power, and energy. Let me see if I can introduce it to that. Okay, work, power, and energy. So we're told that the figure below shows a crane at a construction site raising a steel block of mass 100 kg through a vertical height of 16 meters in 20 seconds. So this is our crane, which was lifting a load of 100 kg through a vertical height of 16 meters in 20 seconds. So the first question says, calculate the work done by the crane. So here we understand that work done is equal to force times distance. Now this again here we also have to understand that force, which is the force which is measured in newtons, can also be weight, and we know that weight is mass times gravity. And this distance they're talking about, the instruction says that it was in a vertical height, which is just h. Therefore, work done can be also written as work done can also be written as where there's force, we understand it can be mass, which is mg, and then the distance, which is a vertical height. So this is what we're going to use. What is our mass? We're told that the mass is 100 grams, 100 kg, which is the right units, no need to convert. The gravity is 10 multiplied by the height, which is 16. So when we compute this, we're going to have 1, 6, 1, we're going to have 1, 6, then we add 3 zeros, which is 1, 2, 3. But the work done is measured in joules. So our answer here, we know that the weight which was done by the crane is 16,000 joules. This was the work done. Then power. Power is the rate at which the work is done. The rate. How much work is done a second, that is power. So capital P is equal to work done divided by time spent. So our work done, we are told that the work done is 16,000, then divided by the time taken, we are told that it was 20 seconds. So the 0 here is omitted and this 0 is omitted. Then we have a 2 going to 16, which gives us 8 with those 2 zeros. So the work, the power, the work done per second was 800 watts. So meaning this crane had the ability to convert 800 joules of energy into a potential energy per second. Yeah, conversion of energy was done 800 per second, joules per second, because that's the power. But when the input power is 1000 watts, the output power is 800. The machine puts in that much of energy in doing this work, and yet the only work which is done is 800. So from here we can see that 200 watts of energy, 200 watts power was not used, had gone into waste. So what would we say? This machine can never be 100% efficient, because when it puts in 1000 watts power, yet the watt which is done, the power which is done as an output is 800. It's not efficient. So how best can we rate this machine in terms of the percentage? So we are going to say that efficiency is equal to power output divided by power input multiplied by 100%. Even when you are calculating the percentage of your, you want to know how much profit you have done. First, you consider what comes out, comparing to what you put in. That's what we're doing here. So what we have as power output is 800. And what we have as power input is 1000. Expressed as a percentage multiplied by 100%. So this 0 goes with that 0. This 0 goes with that 0. This 0 omits that 0. As a result, the efficiency of this machine is 80%. That means when this machine was doing the work, 80% of the total energy applied was used to do work, and 20% of the energy applied had gone into wastage. Now, where did this energy go? That's the question that maybe one might want to know. This energy wastage, in terms of percentage, as in 20%, had been wasted through possible sources are one. You see, when this machine is doing the work, there is a wheel here, and then there is a rope. So we expect some form of friction around here. Secondly, we also expect some air, some sound coming out from that. So there's the friction, there's also sound, as well as any other external factors that could have contributed. That's the reason as to why this machine was not 100% in terms of the efficiency. Do we have questions? Do we have questions? Hmm?
No.
Okay, so we end here. I've given you work already. Please do it.